Good day, everyone. So we are now watching Seeds of Wisdom Tutor TV. Today we are going to consider chemistry as a subject, of which we are going to learn how to calculate relative molecular mass. We can also call it relative atomic mass. So one thing is that we have a compound and we have an element. When we have something like this, potassium is an element. But when you have something like this, sodium chloride. Sodium chloride is a compound. So first thing is that we must be able to differentiate between an element and a compound. So from there, another thing that students find difficult when it comes to calculating relative molecular mass is that some question will come in form of giving them the IUPAC name, and some will come by giving them the common name. Like what we have here on the board, potassium heptaoxochromate 6 is an IUPAC name. So some students, they will not be able to interpret and give the accurate molecular formula. So that is where failure starts creeping. So when you have potassium heptaoxochromate 6, you should be able to write the correct molecular formula. So the correct molecular formula for potassium heptaoxochromate 6 is K2CrO7. So this is a compound. It's not an element. It is a what? A compound. Potassium heptaoxochromate 6. So from here now, we can calculate our relative molecular mass. Some molecular weight, or let's say atomic mass, can be get by multiplying the atomic number by 2, but some cannot be get like that due to isotopes. So we have potassium here, we have chromium, and then we have oxygen. To calculate the relative atomic mass now, we start by potassium. The atomic mass of potassium is 39. Though you want to go by the atomic number that is 19, 2 times 19 you will get 38, but due to isotope, we have to get it as what? 39. So you see these subscripts, these atoms, that is, we are going to multiply it by 2, then plus the atomic mass of chromium approximately is 52 or 51.99, but approximately is 52. But here, chromium did not have any atom or any subscript. So let's close it like this. Then plus the atomic mass of oxygen is 16, and we have 7 atoms of oxygen here. So we have what? 16 times 7. Then by this, we multiply them and then we add everything together. We have gotten our relative molecular mass. Let me have the calculator. So 39 times 2 is equal to 78. So we have 78 plus 52 plus 16 times 7 equal to 112. So this is the first step. The first step, when you have not been given the molecular formula, for you to get the right answer is that you have to derive your molecular formula by yourself. But if you have been given, we have it, then you must also know your atomic mass or mass number of each element to derive the relative atomic mass of a compound. Getting to this step, you are going to add up everything together and arrive at your final answer. So the final answer is 242. So the relative molecular mass of potassium heptachromate 6 is 242. That is the relative molecular mass. Final answer. That is the answer for what? Relative molecular mass of what? Of potassium heptachromate 6. So that is for number 1. So for number 2 also, we were not given the molecular formula. The molecular formula is not being given, but we are given the common name, or let me say the name. Yes, let me say the common name, glucose. So for a chemistry student, you should be able to know how to arrive at the correct molecular formula of a compound. So glucose is having C6H12O6. It's having C6H12O6. C6H12O6. So you want to solve for that now. The molecular weight, or let me say the atomic mass of carbon is 12. Then 12 times 6 plus, let's put the bracket, plus 1 times 12 plus 6 times 16. So I believe you get it right. You first multiply. So 6 times the atomic mass of carbon, which is 12, this is it, plus atomic mass of hydrogen is 1 times 12, plus atomic mass of oxygen is 16 times 6. Everything, this one will give us 72 plus 12 plus 96. Altogether is 180. 180. 180. That is the molecular, that is the atomic, sorry, that is the relative molecular mass of glucose. I believe it has a unit, yes, that is gram per mole. This one also is gram per mole. No, there is no unit for relative molecular mass. Yes, there is no unit for it. So it's just 242 and then 180. So let's come to sodium nitrate. That is the third question. Sodium nitrate. Sodium nitrate is right like this, NaHNO3. Sorry, you can see that is where the error starts. When you don't get the right molecular formula for a compound, you miss the answer. It's sodium nitrate is NaNO3. So sodium triazonitrate 5. You can call this sodium triazonitrate 5, or we said sodium nitrate. So from A, the atomic mass of sodium is 23. There is no subscript, there is no atom there. You can solve forward. Plus atomic mass of nitrogen is 14. Plus we have no that of oxygen we want to be 16 times 3 because it's having what? 3 atoms of oxygen. So 23 plus 14 plus 16 times 3, 3 times 6 is 24, 3 times 1, 3 plus, that is, I think it's 54. Let's confirm that. 16 times 3, yes, it's 48, rather. It's 48. That is 48. So adding everything up, we're going to have 48 plus 14 plus 23. So the final answer for sodium triazonitrate 5 or sodium nitrate is 85. Is 85. The last question that we're going to solve for today is called limestone. When students see limestone and students were unable to write the correct molecular formula for limestone, that is where this failure starts. So the molecular formula for limestone is CaCO3. You count that. I believe that you know limestone is what is the common name. The IUPAC name of limestone is what we call calcium triazocarbonate 4. Calcium triazocarbonate 4. So the atomic mass of calcium is 40 plus atomic mass of carbon is 12 plus that of oxygen is 16 times 3. Then 40 plus 12 plus 48. Everything all together, we're going to have 100. So that is the final answer. So for today's tutorial, this will be the end of the class. I believe with this little explanation, by next time you come across relative atomic mass or relative molecular mass or relative molecular weight, you should be able to do something on it. I wish you best of luck.